All right, let's take it to the next level. What we've done are first order partial derivatives. There's only two choices if you have two variables, x or y. When you go to second order partial derivatives, there are four possibilities. So what's this all about? Notice there are now two indicators down here for your derivatives. What is this? What's this telling us to do? Okay, so if we have the derivative with respect to x, we could then continue to take a second derivative, but of course we have the choice again. We could take the first derivative with respect to x, either with respect to x a second time, or we could take that derivative with respect to x, when we do it the second time, with respect to y. So this derivative could then lead you to this second derivative or this second derivative. Same thing, if you have the first derivative with respect to y, you could continue and take your second derivative with respect to x, or you could take your second derivative with respect to y again. So four different combinations of derivatives. Okay, let's see it in action. I think I have a note here. Oh yeah, if you see them mixed, especially like xy versus yx, always go left to right. So this would mean take the derivative with respect to x, and then your second derivative is a y. Versus here, first derivative is a y, second derivative is x. Okay, a lot of x's and y's going on in this notation. Let's look here. Find all four second order partial derivatives. This is the same function that we started this section with. F of xy equals 3x squared plus 10y. One to start off simple. Find all four second order partial derivatives. Okay. So we need to begin with the first order. Let's start with the derivative with respect to x, and we saw this earlier, right? That derivative is just 6x. Okay. Now let's find the two that stem off of this. And I think I've just got them right here and here. So if I take it with respect to x a second time, then, well, just a normal derivative in that case, it would be 6. However, if I then decide to switch and take the next one with respect to y, well, I don't see any y's there. X is a constant. It's all just a number, so that derivative is 0. Okay, now let's look at the other two. Let's begin with the derivative with respect to y from the original. Okay, so that was 10. And here are the two that come from that one. If fy xy equals 10, then if I go and look at the derivative with respect to x, well, it's just going to be 0. Same thing if I look at the derivative with respect to y. I've still got the 10, so that derivative going to be 0 as well. This isn't uncommon when you get to second derivatives that they just come out as numbers, even 0. Here, 3 out of 4 were 0, and the other one was just a number. Well, that's because our original only had a square, and so by the time we get to those later derivatives, things are disappearing pretty quick. But that doesn't have to be the case. Let's try a harder one. This time, we're not going to find all four, because I think that would get tedious, and I don't think we need that to drive home the point. So we're going to find the two partial derivatives that stem off of the derivative with respect to x. So we're going to find fxx, xy, and we're going to find we're going to find fxy, xy. Here's our function, a little bit more difficult. Fxy equals 3 natural log x over y squared. Okay, well, we know we need to begin by finding the first derivative with respect to x. So let's do that. Again, we have a quotient rule. That's the way I approached it. Let me walk you through my steps. So fx, xy. All right, well, I've got low, d high, 3 natural log x, right? 3 times 1 over x. I'm just going to write it as 3 over x so I don't have, make my work go a little quicker. So low d high minus high, I just copy that. D low, well, the derivative of y squared, if it's with respect to x, going to be 0. And I divide the whole thing by the low squared, the original low, y squared squared. If we start to simplify, well, 0 times all of this, that all just vanishes. Here's how I'm going to think of it. I'm going to multiply this y squared up with the 3. 3y squared over x. And of course, this denominator is y to the 4th. I then included this extra over 1 so that I can go further. If I don't have that, right, I've got a fraction inside of a bigger fraction. So I'm going to think of them both as fractions, because if I have a fraction over another fraction, you may be familiar, I can take this one, flip it, and multiply in order to work towards simplification. So I'll take the y to the 4th over 1, flip it, and multiply. And now I can see something nice. Y squared will cancel. And I'll be left with fx xy equals 3 over xy squared. There's my first order partial derivative with respect to x. Okay. Now, to go further, we need to find the derivative with respect to x again and the derivative with respect to y. Let's start with respect to x again. So that's fxx, another quotient rule. Low, d high, well, d high is just 0, minus high, d low. Let's talk about that. The derivative of the low, well, it's with respect to x. That means y squared is a constant. So I've got x times a constant. The derivative of x is 1. The constant tags along as a constant multiple. So the derivative of my low here is 1 times y squared. I'll just write y squared. Low d high minus high d low, all over the original low quantity squared. And of course, that's the difficult part. Now it's just a matter of simplifying it. So, well, multiplying by 0, that's gone. Let's go ahead and square that denominator. So we've got x squared y to the 4th. Y squareds end up canceling again. And now our second order partial derivative, both with respect to x. Negative 3 over x squared y squared. There's our first answer. All right. I'm going to copy that first order derivative with respect to x again. It was 3 over xy squared. Now we need to take this derivative with respect to y. Here it is. Again, let's walk through it. Well, low d high, that didn't change compared to the previous one, right? So we still got low, d high is still 0, minus high. Now this is different. We are now taking the derivative of xy squared with respect to y. So that means x is a constant. So what's going to happen? If that's a constant, this 2 is going to multiply down, and the power of y drops, right? So we're taking the derivative of y squared, right? So the 2, and I'm just going to think of the 2 moving all the way out in front. 2xy. The x just carries along like a constant multiple. Low d high minus high d low, all over the low squared. Well, that's still quantity xy squared squared. Now it's just a matter of simplifying. Obviously here, that's the challenging part. Cleaning it up, well, the 0 times that, squaring the bottom. We've got negative 6xy over x squared y to the fourth. Now both an x and a y cancel, and there's our answer for fxy, negative 6 over xy to the third. Okay, that is the end of 7.2. You may be wondering, oh, second derivatives, how's that going to be useful? Oh, wait till you see 7.3. We're going to find maxima and minima with our second derivatives. But that's it for now. You won't get that for another couple days. Go check out the homework. See you in the live meeting.